Welcome, Calculus AB. This is section 4.5, Integration by Substitution. There is no essential question. Let's begin. So first part of this is about pattern recognition. What if I gave you a problem like this, and we haven't found a rule or talked about a rule that where you could do this antiderivative. So you could do this by recognizing a pattern. And if you thought about the chain rule, if you think about it this way, this function inside the squared part, if you call that f, this would be like your chain rule of that f prime. So if you see that pattern going on here, you might come up with your antiderivative being the quantity x squared plus 1 squared over 3 plus c. And that might make sense because if you took the derivative, that's cubed, excuse me. If you took the derivative of this, you'd end up getting this with the chain rule. Alright, so maybe sometimes you can recognize the pattern, but sometimes the pattern's not hard to figure out, so we have to use substitution. So what is substitution? If you don't know there's the rule for the antiderivative and you can't think of the pattern, you use this substitution. I wrote down these steps. You have to figure out an expression for u, so you have to set u equal to something. And then determine du. Basically just take the derivative of whatever that expression was, and it'll be u equals something dx if we're doing with respect to x. Then you'll substitute that u and du into the function so that there's only u's left. And then you solve it, and then you got to substitute back. So what does that actually look like? Let's do an example. So I'm going to go back to that same problem. Now the first step here is to figure out my u is. And usually this is going to be something that is inside the function right here. So it's like an inner function. So in this case, an inner function might be this x squared plus 1. So for step 1, I'm going to set my u equal to x squared plus 1. Now your du is just take the derivative of x squared plus 1, which will be 2x dx. Alright, now I want to actually substitute into this function here. So I'm going to substitute x squared plus 1. I'm going to put a u right there, so it's going to be the integral of u squared. And this 2x dx, well, that's substitute for the 2 du right here, so it'll be u squared du. Alright, and what is the antiderivative of u squared? Well, that's going to be u cubed over 3 plus c. And I don't want to leave it in u because the original function was in x's, so for this u, I'm going to go back and substitute x squared plus 1. So my final answer is going to be x squared plus 1 cubed over 3 plus c. And that's what we got in that last problem. If you look at my calculator, I figured it out over here. It's the same answer. So use substitution, one way to make this work. Let's try a different problem. What is the inside function? I don't have a rule for the square root of 2x minus 1. We haven't done that, so I have to actually make a u substitution. And I can say that u equals the inside of the square root, 2x plus 1. You're always looking for something inside. That's usually a dead giveaway there. So that makes your du is going to be 2 dx. Then you're like, wait a minute, I don't have a 2 dx here. But wait, what if when you have just a number, a coefficient like this, we can actually rearrange this function. So I'm going to divide both sides in this by 2. And so your answer is, let's call this 1/2 du equals dx. So when I actually substitute this in, I'm going to have to multiply by another 1/2. So this is going to look like the following. You're going to have the integral of the square root of u and then times 1/2 du. And I'm going to rearrange this. When you have this times 1/2, it's weird right here. So I'm just going to put it on the outside. 1/2 times the square root of u du. What is the antiderivative? And the antiderivative of a square root of something, we've done that in class, should be u to the, well, it's going to be 1/2 times u to the 3/2 power times the reciprocal, which is going to be 2/3 plus c. And the 2's end up canceling here. So I can rewrite this as u to the 3/2 power over 3 plus c. But I don't want to leave it as u's because the original was in x's. So I'm going to substitute my 2x minus 1 in for u. And your final answer is going to be 2x minus 1 to the 3/2 power over 3 plus c. So there you go. Use substitution. Now, what about definite integrals? So we can still use substitution with definite integrals, but there's a little change. When you change those u's, you also need to change the upper and lower limits. Those are those numbers, the upper limit and that's the lower. So those are going to change when I change the variable from x to u. So let's actually do this problem. So what's my u substitution going to be in this case? It is going to be, I want to write it in green. the inside of that cubed, so it'll be u equals x squared plus 1. And that means du is going to be 2x dx. And I have an x dx right here, but I don't have that 2. So I can rewrite this and divide by 2 and say 1/2 du equals x dx. As you get better at this, you can just start realizing that, oh, that just means multiply by a 1/2 over here if I don't have that 2. So substituting that in, it's going to be a 1/2 times the integral of, it's going to be u to the third power du. But what are my limits here? Well, this is where we plug in. If this was when x equals 1, what does y equal? And I'm just going to go back to this function right here. So I'm going to use it. I'm going to make a little table. It helps me out here. If this is x, what is u? When x is 1 and 0? Well, when x is 1, u is going to be 1 squared plus 1, or 2. When x is 0, it's going to be 0 squared plus 1, which is 1. So my integration is going to be from 1 to 2. All right? And so I'll get 1/2 times u to the fourth over 4 plus c. Actually, there's no plus c. My bad. So it'll be u to the fourth over 8 from 1 to 2. And you can plug that in. So it'll be 2 to the fourth power over 8 minus 1 to the fourth power over 8. 2 to the fourth power is 16, so 16 over 8 minus 1 over 8. That is going to be 15/8 as your final answer. That's it. Oh, and you want to check this on a calculator. Let's actually plug this in because I want to practice this. So second, the integral sign, I'm going to type in x times x squared plus 1 to the third power. And with respect to x, and then with respect to the lower limit first, 0, and the upper limit, 1. Oh, no, what did I do? You can't imply something. Oh, it has issues with that. There we go. And I got 15/8. Yay. All done.